All right, section 7C, number 5. It says explain why the probability is the same for any particular outcome of 10 tossed coins. Okay, so you could get a heads, tails, heads, tails, heads, whatever. And that toss, any combination of heads, tails, head, tails, tails, head, is the same as all heads. And all tails. And so it shouldn't surprise someone to get 10 heads in a row, just like it's similar to get heads, tails, heads, tails, heads, tails, head, tails, head, tails, head, tails. That pattern is just as difficult to get as all heads or all tails. Okay? And that's what they wanted you to talk about. Okay, number 15. 15 says you are given 6-to-1 odds against tossing 3 heads of 3 coins, meaning you get $6 if you succeed and $1 if you fail. So, tossing 3 heads. Well, that could be head, tail, then head, tail, and then head, tail, head, tail, head, tail, head, tail. So there are 8 possible outcomes. One that has 3 heads in it, and one that has 3 tails, and then 3 with 2 heads and 3 with 2 tails. And odds against 3 heads in the coin. So if you get heads, 3 heads, which happens 1 out of 8, you get $6. So the value times the probability of that value, plus the other one is minus $1, you lose $1. If you get something besides 3 heads, which there are 7/8 ways to get not 3 heads, and so you get 6/8 of $1 minus 7/8 of $1, which is negative 1/8 of $1. If you want to change it to decimal, it's 0.125 or 12.5 cents. So if you play this game with a 6-to-1 odds, they'll give you $6 if you win, $1. You have to pay $1 if you lose. You're gonna lose, dollar 12.5 cents per play on average. Now, it says, how much money do you expect to win in one game? Well, if you only play once, you're either going to win 6 or lose 1. And what do you expect? Well, 7 out of 8 times you'll lose 1. So if you play once, you're probably going to expect to lose $1, unless you're a tremendous optimist. But if you play 100 times, then you would expect to get approximately $12.50 in total losses, because that 12.5 cents times 100 times is $12.50. You expect to get somewhere close to there. Now, there's no way you can come up with a 50 cents gain or loss, because that doesn't happen. So somewhere around negative $12, negative $13, negative $11, negative $14, somewhere in that area is where you expect to come out. Okay, that's 15. Then we have 16, which is a similar type problem. 9-to-1, you get 3 heads on 3 coins, meaning you win 9 and you lose 1. So using the same, so you win 9 times 1/8 and lose 1 times 7/8. So you get plus 9/8 minus 7/8 is plus 2/8, which is 1/4. So you expect to win 25 cents per roll. Again, 1 roll, you probably expect to lose $1. On 100 rolls, you expect to win $25. And you could get $25 because that's an even value, not cents. Okay, so somewhere between around $25 is what you, around 25, not exactly 25, but around 25. And then 17 is another similar problem. 2-to-1 odds and rolling two even numbers and two fair dice. Two even numbers. Well, two even numbers, if you roll the dice, two even numbers are 2 and 2, 2, 4, 2, 6, 4, 2, 4, 4, 4, 6, and 6, 2, 6, 4, and 6, 6. So there's 9 of them. So if you're given 2-to-1 odds, you get $2. If you get this, which is 9 out of 36, or 1/4 of the time, and you pay $1, 3/4 of the time, so that's 1/2 or 2/4 minus 3/4, which is negative 0.25. So you expect in one toss to, probably 3 out of 4 times you did, you're expecting a loss of $1. If you play 100 times, you're expecting to lose $25. 0.25 times 100. 18. 18 now is 7-to-1 on rolling double number. Okay, so double, 7-to-1. So doubles happen 6 out of 36, or 1/6 of the time, and if you do that and you're given 7-to-1, you're going to win $7. And the rest of the time, you're going to lose $1, and that's 5/6. So you get 7/6 minus 5/6, which is 2/6, or 0.33, 33 and a third cents. So one toss, you're going to lose $1, probably. But if 100 tosses, you're going to expect to lose around $33. Somewhere in that neighborhood. Okay, so that's those.